The man in this picture is Archimedes. Archimedes was an ancient Greek mathematician, and one day the king of Greece came to Archimedes and said, Archimedes, I have just had a crown made for myself, and I wanted the crown made out of gold. However, I'm unsure about whether the blacksmith has made it out of gold or whether he's added in some cheaper, inferior metals, maybe like copper or lead, to keep the cost down and rip me off. I'm not even sure if it's gold at all. So Archimedes, I want you to work out whether this crown is made of pure gold or not. So Archimedes thought about this and he realized, hey, if I know the density of gold, I can compare that to the density of the crown and figure out whether this crown is real or not. So if you knew the density of gold, which is 19.3 grams per centimeters cubed, he could compare that to the density of the crown. And again, if they were the same, it means that the crown is made of gold. If the densities are different, then there's something else instead of gold. So what happened was, he realized the equation for density is equal to mass in grams divided by volume. And he was easily able to determine the mass of the crown by putting it on a scale. But the volume was a little bit difficult, and that's because that the crown is an irregular object. Oops, irregular object. And how do you determine the volume of an irregular object? If it was a cube or if it was a rectangle, you could use length times width times depth, but this is not a cube or a rectangle, so how is he supposed to do that? He was very confused by this, so he did what any good scientist that's confused does. He jumped in the bathtub and he added some water and he hopped in, and as Archimedes hopped in, he noticed something. Maybe we've noticed this at home as well. The water level rose as he put his body in the water. It actually got so high it started to overflow. And it was at that moment Archimedes realized, hey, I figured out how to work out the volume of the crown. The story goes, he jumped out of the bath, ran down the street naked, yelling Eureka. Now, what did Archimedes do, and how did he determine the volume of the crown? Well, he used what's called the displacement method. And the displacement method basically says the amount of water that's displaced by an object is equal to the object's volume. And I have that written right here. It says, when an object is placed in water, it pushes the water away. The object is displacing the water. And the amount of water in milliliters that the object displaces is equal to the object's volume. Okay, well, let's think about that using another little example. Imagine a measuring cylinder. And imagine in that measuring cylinder, we added 10 milliliters of water. And then to that measuring cylinder, we added an irregular shaped rock. And when that rock settled at the bottom and the water level settled, the new level of the water was 15 mils. Well, the displacement method says that the amount of water, so up here, the amount of water in milliliters that the object displaces is equal to the object's volume. So the volume of the object is equal to 15 milliliters. So the object volume of the rock, is equal to 15 milliliters minus 10 milliliters. And that is, of course, 5 milliliters. And the volume of the rock is therefore 5 centimeters cubed. So I guess a simple way to think about this is for every, if I write it up here, every 1 milliliter of water that's displaced, the volume of the object is 1 centimeter cubed. We can add to it 1 centimeter cubed. So let's solve some questions that use the displacement method. Question 10 here says, in 15 milliliters of water, a shell displaces the water by 3 milliliters. The shell weighs 6 grams. Determine the density of the shell. So the equation for density, which is measured in grams per centimeters cubed, is equal to mass in grams divided by volume in centimeters cubed. And the mass can be determined by rereading the question, and the mass is right here, grams. The shell weighs 6 grams. So 6 grams goes in our numerator, and what goes is our volume. So reread the question again. It says 15 milliliters of water. A shell displaces the water by 3 milliliters. So just think about that on the side here. We know that for every 1 milliliter of water displaced, the volume is equal to 1 centimeter cubed. So therefore, if it's 3 milliliters of water displaced, then the volume is 3 centimeters cubed. And so therefore, if we go back to our equation over here, the volume of the shell will be 3 centimeters cubed, and 6 divided by 3 is equal to 2 grams per centimeters cubed. And we've just measured our density. Now let's take a look at some of the features of how I've presented this. I've got my equation at the top here. I've got my working line. I've included my answer. I've got my answer, and I've got my units, and I've underlined my answer, and everything's nice and neat and nice and lined up. So there's no reason I should lose any marks for this question. Let's have a look at another question that uses the displacement method. Question 14 says, once a wooden block is added to 7.2 milliliters of water, the volume becomes 22.7 milliliters. The wooden block weighs 31 grams. Determine the density of the wooden block. So density, again, is measured in grams per centimeters cubed, and it's equal to the mass in grams divided by the volume in centimeters cubed. Now the mass can be determined by rereading the question. It says here the wooden block weighs 31 grams. So 31 grams. Now what's the volume? Well, the volume is going to be, we have to think about that in terms of the displacement method. So the volume of the water starts off at 7.2 milliliters and becomes 22.7. So let's do up a little side equation here. I know that for every 1 milliliter of water that's displaced, the volume is equal to 1 centimeter cubed. So 22.7 milliliters minus 7.2 milliliters. Okay, let's go over to our calculator and do that one. 22.7 minus 7.2 is equal to 15.5. And therefore, volume is 15.5 centimeters cubed. So whoops, let me change the pen back. So 15.5 centimeters cubed, and we can then go back to our calculator and work out 31 divided by 15.5, and that answer is 2. So our answer is 2 grams per centimeters cubed. Again, let's have a look at how I've laid out my answer. I've got my equation, I've got my working line, I've got my answer, I've underlined my answer, I have my units, and all my equal signs line up.